Start by taking a piece of chromatography paper and draw a pencil line near the bottom. This line will serve as the starting point for the separation process. Remember, drawing the starting line in pencil is essential because using pen ink would also move up the paper with the solvent, making it difficult to observe the separated substances. Place small dots of different colored substances, such as pens, on the pencil line. You can use multiple colors as long as there is enough space on the paper. The next step involves placing the bottom of the paper into a solvent. A solvent is a liquid that can dissolve substances. As the solvent moves up the paper, it dissolves the ink in the colored dots and carries them along. The paper is made up of a stationary phase which does not move, and the solvent acts as the mobile phase, moving up the paper. After some time, the paper may show separated spots of different colors. A single spot indicates a pure substance, while multiple spots suggest a mixture of substances. Each chemical in the mixture is attracted to the stationary phase to a different extent, causing them to separate. It's important to note that a pure chemical will produce a single spot in all solvents, while the chemicals in a mixture may separate into different spots depending on the solvent used. The position of the spots may change when using different solvents, but the presence of a single spot indicates a pure substance. RF values are important in identifying compounds because different compounds have different RF values in different solvents. These values can be compared to known RF values in databases to help determine the identity of the compound. To calculate the RF retention factor values in paper chromatography, follow these steps. Measure the distance from the starting line to the center of the spot for a particular compound, distance moved by the compound. Measure the distance from the starting line to the solvent front, distance moved by the solvent. Divide the distance moved by the compound by the distance moved by the solvent, RF equals sign, distance moved by compound, distance moved by solvent. The resulting value is the RF value for that compound in the specific solvent used. Here are some exam questions to do. Pause and have a go. Here is the answer. Did you get it right?